The lesson topic for this video is special right triangles. Alright, so you've learned about special right triangles before in geometry class, typically, and I want to remind you that our two special right triangles, obviously they're right triangles, so they have a right angle in them, but the first special right triangle is what we call the 30, 60, 90 right triangle, and that's because there's an angle that's 30 degrees, and an angle that's 60 degrees, and an angle that's, of course, 90. The second one is the 45, 45, 90 triangle, which you can imagine means that there's a 45 and another 45 degree angle, and then our 90 degree angle. Obviously, 60 and 30 adds up to 90, plus this 90 means 180 degrees, of course, and then 45 and 45 add up to 90, plus the 90 gives us 180 degrees in this triangle. So you might remember that our two special right triangles are special because there's a very easy way to determine a side length if you're given another side length. So there's this quick shortcut or quick rule to the sides. Let's remember what that is. First of all, the 30, 60, 90 triangle. If the shortest leg of the 30, 60, 90 triangle, and let's remember that we know that the longest leg of any triangle is across from the largest angle. So if this is our 90 degree angle, this is our longest side, or hypotenuse. Well, we also know that across from the smallest angle, opposite the smallest angle, is the smallest side, or shortest side, and across from the medium, in this case, the medium angle in the middle here, across from that is the side of the triangle that's in between the longest and the shortest. So this will be the shortest and the longest and the medium length side. Okay, so we know that the shortest side, which has to be across from the 30 degree angle, okay, is, if it is, 1 unit long. So let's say it was 1 foot or 1 inch or 1 meter, okay? Then, let's make that a obvious one, that means that the hypotenuse across from the right angle will always be 2. So that's the shortest side and the longest side, 1, and twice that is 2. And that means this side here, well, it is going to be root 3, the square root of 3. Now technically it's 1 times the square root of 3, but in this case we can just say it's root 3. So 1, 2, and root 3. Now think about this. If this was 4, though, instead of 1, if this was 4, then this would be 8, and this would be 4 root 3. Maybe remember that from, again, geometry class. But for now, what we have to remember is that across from the 30 degree angle is 1, across from the right angle is 2, and across from the 60 degree angle is root 3. 1, 2, root 3. Now the 45, 45, 90 triangle. Well, obviously we are going to know that this side and this side are the same length because they are across from two angles that are the same measure. So this is the same as this. So let's call those both 1. Okay, so 1 there. That's not a very good one, so let me rewrite that. So 1 here, and this will be 1 here. So the two legs that are across from the 45 degree angles are 1, and that will leave us with a hypotenuse, which is the square root of 2. Now, just so you know, I think it's kind of important. You don't have to even write this down, but please watch this and think about it a little bit. If I had used the Pythagorean Theorem, a squared plus b squared equals c squared, and I put a 1 in for the short side, squared, plus 1 in for the other side, squared, so that would be these two sides here, we can solve for the hypotenuse, right? Well, 1 squared is 1, plus 1 squared is 1 equals c squared. 1 plus 1 is 2 equals c squared. So now we square root both sides, and what do we get for c? Well, we get c equals the square root of 2, which is why the rule works. This is always going to be the square root of 2. We could have done the same thing over here with this triangle. We could have talked about this as being a and this as being c and found that the square root of 3 would be the long side. So, again, to summarize this, if we have a 30, 60, 90 triangle, we're going to have side lengths of 1, 2, and root 3, and you absolutely need to know where they go in the triangle. And with the 45, 45, 90 triangle, we'll have 1, 1, and root 2 for the hypotenuse. So what we're going to do, connecting the special right triangles to trig, is we are going to find the sine, tangent, cosecant, all these things. We're going to find those of these special angle measures that show up in 30, 60, 90 triangles. So before we start filling in the ratios for these, let's go through and label our triangles with the side lengths. I would prefer, if you would be willing, please, pause the video, fill them in without looking at your notes, and then check back to see if you filled them in correctly. So we just went over this, just hoping that you remember and can transfer it to a blank diagram. Okay, so hopefully you put 1 here. Man, I can't draw 1. Okay, 1 here, 2 at the hypotenuse, and root 3 for the long side. And for our 45, 45, 90, 1 here, and the square root of 2 there. So, first of all, sine of 30 degrees. We're going to fill in that ratio. Well, 30 degrees occurs in our 30, 60, 90 triangle, so the sine, we know the sine ratio is opposite over hypotenuse, so it's going to be 1 over 2. Tangent of 45. Well, the 45 degree angle shows up here, so the tangent of 45, well, tangent is opposite over adjacent. It doesn't matter which 45 degree angle you choose here, they're both going to give you the same answer, so opposite is 1 over adjacent is 1. So the tangent of 45 is 1 over 1, or just 1. All right, cosecant. Now think for a minute, what is the cosecant ratio? Well, the cosecant ratio is the reciprocal of the sine ratio, right? The sine ratio. So if the sine ratio is opposite over hypotenuse, the cosecant is hypotenuse over opposite. All right, so the hypotenuse in this 30, 60, 90 triangle is 2, and the opposite side of the 60 degree angle, here 60, the opposite side is root 3. So 2 over root 3. Some of you might have learned in the past about rationalizing the denominator, which means leaving our denominator without a square root. You do not have to worry about that. We're going to leave these just as they are. All right, secant of 45 degrees. Well, the secant is the reciprocal of the cosine ratio. Cosine is, and again, if you haven't done this yet, oops, sorry about that. If you haven't written this down yet, SOHCAHTOA, it might have helped you before we got started here. Sorry about that. SOHCAHTOA, okay, so if we know that secant is the reciprocal of cosine, it's going to be hypotenuse over adjacent. The hypotenuse in the 45, 45, 90 triangle is square root of 2, and the adjacent side of the 45 degree angle is 1. So square root of 2 over 1, or just the square root of 2. Cosine of 30. Again, pick the right triangle, the 30, 60, 90 triangle. Cosine is adjacent over hypotenuse. The adjacent to the 30 degree angle, the adjacent is root 3 over the hypotenuse is 2. So root 3 over 2. And lastly, we have cotangent. All right, if the tangent ratio is opposite over adjacent, the cotangent is adjacent over opposite. So we need the adjacent side of the 60 degree angle. Here's 60. Adjacent is 1. And then we need the opposite side on the bottom. The opposite of the 60 degree angle is square root of 3. Again, I probably should have written this at the beginning of the slide, so if you want to just go back and look at those first examples with it written there, that might be handy. All right, more practice with this in class.